Good morning everyone, welcome to ESUC 2020. My name is Benjamin. Thank you for joining us in this very special ESUC. We are connecting from home, and I must admit that it is a very challenging time for everyone. Challenging not just because of COVID-19, but because of the world that we live in, the multiple challenges that we face in our daily lives. And therefore it is important that we forge a resilient future together. We could do this using geography, through its applications and its science. For the past 50 years, it has been the cornerstone of Esri and our products. Geography helps us organize our thoughts, and its applications help us realize the solutions to solve our challenges. Forging a resilient future requires understanding, communication, and collaboration. And it is only through collaboration that we are able to leverage on one another's strengths to build better and better solutions. Therefore, geography, the science of our world, provides us a way to integrate our different sciences and different disciplines together. GIS then gives us the tools and technology to help us do so by modeling, visualizing, and helping us understand our world. And it is only through understanding that we are able to take intelligent actions. And users every day are integrating every type of data and format. Users are integrating tabular data, unstructured data, raster, real-time, vector, and publishing them as ready-to-use maps and data layers. And this is what we call altogether geospatial infrastructure. The geospatial infrastructure is the modern GIS implementation pattern. Through collaboration, it leverages on services-based architecture and the data that has been published. It engages everybody from individuals to teams to organizations, departments, and now it is extending to communities. It is about sharing and collaborating, interconnecting everything to build a resilient future. Geospatial infrastructure is transforming organizations as these organizations are embracing the new technologies such as AI, cloud computing, advanced analytics, machine learning. They are bringing together real-time data, shared services, publishing information through apps, and integrating all of these into all aspects of their organizations. Here we have a case study on interconnecting data. This is Spacer, an initiative by the National University of Singapore. This web app was built on Dashboard, App Builder, and StoryMaps. On this web app, you can find out the crowd levels in the various buildings around the campus. The information on crowd levels are shared by beacons, but you can extend this idea and extend it to other sensors, such as crowd detection or security feeds. Using such information, students and visitors alike, they can then make rational and informed decisions on where to go, when to go, to maintain social distancing, thereby increasing our resilience in the fight against COVID-19. Esri's main vision is to build tools that help everyone do their work better. The aim and the vision of ArcGIS is to build a comprehensive geospatial platform that supports multiple communities. We have location services to help power your applications with context. A feature about location services is geo-enrichment. Given a point, geo-enrichment allows data, enriches the data with average income, for example, or household size or population density. We also support the developer community by making it possible to extend our platform by building software and software as a service. We refer to all of these as geospatial cloud. ArcGIS is increasingly cloud native. Cloud native means implementing software so that it is cloud first in its engineering. And Kubernetes is designed for running software in such a distributed cloud environment. You can think of Kubernetes like a new operating system such as Linux or Windows. What does cloud native mean for you? It means that the software is refactored and it can be really scalable and takes advantage of distributed computing. My colleague Abhijit will talk about that more in details. ArcGIS is by design an open platform for innovation, and let me show you why. There are open standards that we support, more than 100 data formats, metadata, and services. We have APIs that ArcGIS use to combine functionality into compelling and interactive applications. APIs are available in Python and in JavaScript. We support open data. Open data capabilities are included right out of the box in ArcGIS, and there are many open source data that's available that can be ingested into ArcGIS. ArcGIS is also compatible with open source. We have shared more than 350 open source projects on GitHub and provide many focused solutions for customizing and extending ArcGIS. And we continue to do so every day. ArcGIS is also extendable to rich tools like Python, R, TensorFlow, to develop very complex systems such as machine learning, artificial intelligence, and statistical computing. The open architecture design of ArcGIS means that it can be deployed in many ways. It can be deployed to mobile devices natively, clouds, both private and public, as well as something like Kubernetes. I will now hand over the presentation to my colleague Abhijit, who will bring you through the top enhancements that we have made, how ArcGIS capabilities are advancing, and the new innovations that will be available to you in the near future. Abhijit, please.
Thank you, Ben. Hi, my name is Abhijit. ArcGIS has many new advances this year, especially in the areas listed on this slide. I will share highlights from these different categories and will share with you my favorite top 5 enhancements. Smart mapping is a capability that is part of ArcGIS Online and Enterprise. With smart mapping, you don't have to be a cartographer to easily make very sophisticated maps. It's about dynamic and data-driven cartographic views and intelligent defaults that are tailored to data being displayed. A couple of capabilities in the new map viewer are cartographic blending that lets you blend your layers in your map for better understanding of what you are looking at, and clustering, which gives you the control over constraint to provide another way to visualize your data. Let me take you to the new map viewer. This is the next generation of online mapping that will help you explore your data quickly and create stunning maps that can be shared across the ArcGIS platform. It's going to launch this fall, but you have access to the new map viewer today and ArcGIS Online. So let me show you how to get started. As we begin to explore the population enriched with the age group in subzones in Singapore. On your organization's homepage, navigate to the app launcher and select map viewer. The map viewer was built with an enhanced, more intuitive user interface. Here we can browse familiar base maps, and I will choose my favorite dark gray canvas. To get started, next let's pull in a dataset of Singapore subzone that have been enriched with population data. We can begin to explore the diverse community in the city using this styling option. To start, we will add the population data and the population attribute. The map automatically updates with a high to low color scheme, but to heighten the visualization, we will change the theme to above and below so the data is centered around the average. Next, we can experiment with the new color ramps that offer a rich and sophisticated palette to better express the data quickly, trying out different options here and there. There are also predefined categories of styles. The histogram changes how the color maps to your data, and you get immediate feedback on the map. The map viewer also introduces another way to visualize your data on the fly called dot density. With this style, it has never been easier and more beautiful. Here one dot represents 650 people, but look at how fast and responsive it's changing. The next one is the clustering. With the updated clustering capabilities in ArcGIS Online Map Viewer, you can easily uncover hidden patterns in your data. It is a lot faster and can handle significantly more points compared to the 50,000 points limit in the classic map viewer. You can change the cluster radius accordingly to the low to the high, and also the size range to the mean and to the max. You can also level the features of the clusters with arcade expressions as well. In the past, if you wanted to see a mountain ranges with color on top of them, you would apply transparency of 30% or more, making the colors wash out for most of the part. With multiply blend mode, there is no need to use transparency, as the mountain hill shading is blended into the colors. The multiply option is excellent for blending mountain ranges with polygons. Story maps are transforming the way that people understand and work with maps. In the last year, we launched a new version of the story maps with many new features. We have optimized for mobile, as earlier this year, we introduced a new user types called Storyteller, so that people across your organization in a very affordable manner can create and share their own story maps. So far, millions of story maps have been published by the GIS community. Dashboards are making dynamic visual reporting a reality, not just the big dashboards in emergency centers, but on the mobile devices, and in fact on any devices. And here we have been making improvements in mapping and especially in performance. Our PhD students earlier this year from Johns Hopkins Civil and Systems Engineering program created the dashboard visualization the world uses to gauge the spread of COVID-19 today. The dashboard is very intuitive. Billions of people saw that dashboard, and it is getting around 3 to 4.5 billion hits a day. One of the new enhancements for the dashboard is support for the arcade expression. This is one of my favorite too. Let me show you. With the ArcGIS dashboards beta, an arcade expression can now be used in the list and indicator element to reveal more information from your data. In the list or indicator tab, you will find an arcade option. Click enable, the arcade editor will open. In this COVID-19 dashboard, in the indicator, you can change the color very easily, which makes it visually compelling. In the list element, I can make it different color for symptomatic and asymptomatic cases. With the ArcGIS dashboard beta, arcade can be leveraged to do this for pop-ups, detail elements, indicator elements, and list elements. Another dimension of GIS that's rapidly changing is real-time visualization and analytics. This is all about integrating sensor networks and Internet of Things data as GIS layers right into the system. Esri has been supporting this capability with the extension to ArcGIS Enterprise called Geo Event Server and Geo Analytics Server. And now we are also supporting it in ArcGIS Online with a new capability called ArcGIS Analytics for IoT. This is one of my favorite enhancements too. This is completely a cloud-based, as Benjamin described earlier, so you can analyze your streaming data on maps and dashboards. You can identify temporal patterns and extract location-based intelligence, all while working at scale in Esri's Geospatial cloud. This is important because it greatly reduces the time between measuring and analyzing and decision making. ArcGIS supports field operations, data capture and inspections and surveys at the center of many of our users' field work. Earlier today, we have seen this in NPark's presentation. ArcGIS Collector and Survey 123 have been widely used for this. Last year, we introduced ArcGIS Quick Capture, which allows at speed, big button data collection with minimal user involvement. Based on the customer request, we are releasing a new app called ArcGIS Field Maps, and it is an integrated app that brings tracking and mapping and navigation and field capture all at one environment. ArcGIS Field Maps will honor all user types and their privileges. Later today, my colleague Minu will share more details about field apps, so watch out for her presentation. In the area of location analytics, we have ArcGIS Insights, a self-service analytics tool made for intuitive, interactive spatial analytics. Insights takes data from almost any data sources and allows you to do the exploration, visual data analytics with maps and charts that are all linked, and then do some advanced analytics as well. ArcGIS is a common platform for managing and applying 3D data. Its 3D capabilities now seamlessly flow across the entire ArcGIS platform, from desktop to the web and to the apps. Today, you can work with a wide variety of 3D data, including point clouds, LiDAR, bin data, 3D models, and large 3D meshes. You can also use 2D data to create compelling 3D visualization and analysis. For advanced visualization, we are also building new plugins for game engines, in addition to the AR and VR support. The example on the right shows the flight through the Australian fires last summer using a gaming engine. Very fast and realistic visualization of various forms. This new way of view 3D information through the game engine will be available later this year. And 3D is not only for visualization, it's also for analytics, interactive measurements, interactive view shades. These are all areas we have been pioneering and pushing. We have introduced a new layer type called voxel for creating 3D volumetric visualization, and we also continue to integrate a wide range of interactive analytical tools across ArcGIS. For example, View Dome and Slice. ArcGIS is a 3D system, means that you can perform 3D visualization and analytics across the entire platform. Earlier, you have seen Saoyong has mentioned about SLA 3D Singapore Sandbox. The sandbox is providing users with the access to SLA's 3D geospatial data, including 3D models of over 160,000 buildings and 2D data from open platform mapped nationwide. Esri Singapore is proud to be part of this ongoing initiative to drive the geospatial innovation through the offering of an open and interoperable platform within the 3D Singapore Sandbox. With Esri technology, every sector and everyone in the open community can develop and test new services and solutions that will add to Singapore's effort in becoming a smart city. Starting from ArcGIS Pro 2.5, you can create, edit, and save Jupyter Notebook as per your ArcGIS Pro project with ArcGIS Notebooks, Esri's Jupyter Notebook environment. The notebook you create in ArcGIS Pro will leverage the ArcGIS Pro Python environment, which you can customize through the Python package manager, the Python command prompt, and through the Anaconda. Next, let's talk about how these capabilities show up in various products. In server technology, we have ArcGIS Enterprise, a comprehensive system that users implement in their own infrastructure or in the cloud. Here too, many improvements have been made in publishing, webhooks, site authoring, plus better administrative options and license management and so on. In addition, we are building a new cloud-native containerized application framework that will result in a new deployment option called ArcGIS Enterprise on Kubernetes, with beta expected later this year. So ArcGIS will run on Kubernetes. You can think of Kubernetes as another operating system, and running on Kubernetes means it's fully optimized to run in cloud-native environment. It leverages many of the advantages of cloud computing, including the distributing and scaling out. It means easier maintenance of your platform, and it means more IT-friendly integration with the other enterprise systems in your organization. ArcGIS Online is our SaaS product for mapping and analytics and location intelligence, and this has been growing very rapidly. It's grown 400% in the last quarter, and more than 9 million users are using it on a daily basis. This year, we are extending it with ArcGIS Analytics for IoT, a new real-time and big data analytics capability for ArcGIS Online itself. We also added a new notebook extension that lets you perform spatial analysis and run automated scripts without having to leave ArcGIS Online environment. And we are also working on the extensions for image hosting and image analytics. Many of our users like to build apps, and we have 3 experiences for building apps. One of them is Web App Builder, which is very popular, and we have deployed over 1 million apps in the last few years. The second one we have been building for several years is called Experience Builder. It's optimized for the mobile. For example, it integrates 2D and 3D into the environment, and it features new mapping capabilities. We have also introduced something called GeoCards in Experience Builder that brings together the maps, story maps, dashboards, infographics as shareable containers of geographic data to create customized web experiences. The third app builder experience is App Studio, which in past has only been available for developers, but at this release we are making it available to all of our users. App Studio allows you to build cross-platform native mobile applications. So without further delay, let me show you a quick look on the Experience Builder demo. Today, organizations across the world, just like yours, are being challenged to build increasingly complex and integrated applications to solve spatial problems and accomplish their mission. And many of you are already responding to that challenge with some combination of 3 or 4 tools. Web app, like this one I just show you, from Living Atlas that tracks hurricanes and severe weather around the United States. The dashboard one is from FEMA that focuses on monitoring critical infrastructure like communications. The story map that I show you is from Nebraska's Department of Natural Resources that details the incredible response to the flooding that accompanied Winter Storm Alma in 2019. And each application on its own is powerful, but what if we could integrate our web apps and dashboards and story maps in one integrated application in a unified location? With ArcGIS Experience Builder, you can build this application interconnected. It takes information, let us see it in 2D as well as in 3D, and dynamically integrates with many of your GIS application. Another area of our platform has been dedicated to a unique group of users who like to work with scripts and codes to build new apps, automations for repetitive tasks, and connect to the data science libraries. With Python API and Jupyter Notebook, developers are able to access desktop and ArcGIS Enterprise to automate tasks and connect to the data science libraries for deeper analysis on their data. The Pro SDK enables developers to extend ArcGIS Pro with add-ins for specific workflows. The Runtime SDK are for building mobile apps and native device apps. And it's also the technology for plugging into the game engines to build rich experiences in the platform. Then there is the JavaScript API, the most popular API in our portfolio. It used to develop browser-based application that supports dynamic analytics and visualization in a browsing environment. Something new that's coming in our API is our REST API. It will be more open to third-party clients and will support open source, open layers, leaflets, and more. Looking deeper into the JavaScript API, here are some of the highlights of the new features that have been added. Blend modes, which are available in the beta version of the map viewer. Some of the new editing capabilities includes the ability to perform 3D editing in a scene, the ability to edit attribute values through a table, and better management of attachment on features. Feature snapping is coming later this year as well. To recap, Esri's main purpose is to build tools that help you to do your work better. In the afternoon plenary, my colleagues Sharon and Boon Hong will talk more about geo-enabled system, and you will also learn more about AI, ML and data science in the breakout session. Thank you.